Okay, so very good morning to all. So actually, welcome to the Pantech Learning Private Limited. Okay, so today the class about the EV designing. Okay, so the 1.5 hour we can detail will check the how we can design the EV from in a MATLAB. Okay, so MATLAB how we can design one EV electrical vehicle. Okay, so I hope everyone can listening this class. Okay, if any problem is there, please comment in the comment box. Okay, so make out the comment box. Okay, so without any delay, directly we can go from the class. Okay, so first of all, what is EV? So EV means electrical vehicle, we already know. So like current days, so the more than fuel engines only we are using, like fossil fuel engines only we are using. So the fossil fuel engines are important, like that we are not thinking, right? What is the reason means the more pollution, at the same time more cost, and the fossil fuel not getting properly, right? So that same time we will increasing the fuel cost also. So this kind of the things we need to reduce without any pollution, eco-friendly system. Okay, so without any pollution, eco-friendly system, at the same time we need to capture the environmental properly. So that's why we are coming from the EV designing. Okay, electrical vehicle designing. Okay, so the current days also we are using the electrical vehicles. Okay, so the recent research, so after the corona period, the electrical vehicle purchasing limits will be increased. Okay, so at the same time, two-wheelers and four-wheelers, all things we are purchasing. Okay, so that upcoming days, so like upcoming years, so definitely the EV is an important thing from all peoples. Okay, so that's why we need to more learn the EV. Okay, the one EV designing part we know means we will achieve some more than company parts. Okay, so first of all, we can directly will go from the introduction part. So already you know about the EV. So what are the types of vehicles is available? Like a conventional vehicle. So conventional vehicle means we will using the like a battery for like a starting and stopping purpose only. Okay, so one vehicle we need to start and stop, and inside some lights purpose we are using the battery. This is only the conventional vehicle. So remaining thing, so like a AC or another things, everything we are using from the fuels only, the major part. Okay, so that is considered from the conventional vehicles. Okay, so the conventional vehicles are upcoming days definitely will be going to the less. Okay, so definitely EV purchasing the unit will be increased. So what is the reason means the the conventional fuels we are not getting properly, at the same time cost. Okay, so so that's why we are using a EV electrical vehicles. Okay, so first of all, two types of electrical vehicles will be available. Okay, so in current market also two types of electrical vehicles will be available, like a hybrid electrical vehicle. So first of all, what is hybrid electrical vehicle? What is the meaning of hybrid? So hybrid means, so two type of things, like two type of different things. Okay, like a hybrid plants we are asking, right? What is the hybrid plants means? Two types of plants is there. The two type of plants we are combining and we are making one plant. So that is considered from the hybrid. Two things, different things you are combining. So same thing only the vehicle side also. Hybrid electrical vehicle means we are using a battery, at the same time we are using a fuel also. Okay, so here what is the use of battery, what is the use of fuel means. So, okay, so sorry for the interruption. Okay, so okay, we will continue the class. Okay, so actually, so the environmental conditions we need to check. Okay, so after that, the limitations. Okay, so limitations means like a charging and range of distance and temperatures. So this kind of thing, like a battery purpose, we need to do some battery management system configurations. Okay, so after that, the energy efficiency, less like a less no power conventional. So like that we need to improve the electrical vehicle efficiency. for this base. Okay, so after that, so the electrical vehicle components, so you can think one majorly one electrical vehicle you are taking means what are the components will be important. So as well as our conventional vehicle, every parts will be coming. Okay, that is the same thing. Sorry. So main thing the components will be like a vehicle wheel and body of the vehicle and gear systems. Okay, so this is comes under the mechanical area. Okay, so this is the first one. Okay, so after that we need a, so like a motor, battery and power controller unit and onboard chargers. So this part everything will be comes under the electrical side. Okay, so like a downside parts, first one is the mechanical parts. Okay, so after that, so remaining parts will be the electrical side, and after finally the assembly. Okay, so other essential components like a vehicle outside parts, so the box and everything we need to comes under the third thing. Okay, assemblies. Okay, so finally we can assembly the vehicle. Okay, so this is the one electrical vehicle main components. Okay, so here only the inverter or converter or rectifiers or everything will be comes under the battery and motor PCU controlling part. Okay, so next one. So these are the EV parts, the major EV parts. Okay. So EV parts means what are the things is there? So one is the vehicle body. Okay. So already we know the vehicle body. So after that we need a motor. Okay. So one motor only will be controlling the speed controlling or like acceleration, brake or everything. Okay. So in this brake purpose we can use the additionally gears and brake systems and everything. Okay. So after that inverter. So the inverter based only we are controlling the motor speed. Okay, so the after battery bank. Okay, so actually battery bank only the initial thing. So after that the battery bank will be sending a voltage from a inverter. Okay, so before that here battery bank nearby we can do some additional DC to DC converter like a bidirectional converter charging and discharging purpose. So after that we can use some boost converters. Boost converter after only we can convert to the DC to AC with using of inverter. So inverter after we can controlling the motor. Okay, so motor speed. So finally we can connecting the wheels. Okay, the axials is the wheel we are connecting. Based on the motor rotation, the wheels will be rotating and will controlling speed. Okay, so this one is the onboard charger. So lot of number we will check our electrical vehicle means the electrical vehicle one additional one cable and one type of box type one the every person will make it. What is the thing means like a one type of onboard charger. Okay, so in this onboard charger inside the bidirectional converter and boost converter, this kind of the things is there. So this kind of the circuits only inside the onboard charger is there. Without onboard charger, we cannot charge the vehicle. Okay, so that's why the every electrical vehicle we will give the onboard charges. Okay, so the next thing, the block diagram. Okay. So this is the one block diagram of the electrical vehicle. Okay. So here what are the things is there? So one is the driver. Okay. So driver is the main part of the electrical vehicle. Okay. So we are the control signal we need to generate. Okay. So we are the uh, drivers only we need to generate the control signals. Okay, the control signals we are giving the motor controlling part. Okay, battery will be sending a power supply from motor control. Okay, so how much voltage we need to expect the based on the voltage the motor controller will be taking. But our acceleration based how much duty cycle we need to apply, like you know the duty cycle. So on motor we need to control means based on the duty cycle range only we are controlling the speed. So like you can take 0 to 100% duty cycle. Suppose I am applying a 10% of duty cycle means my motor will be rotating a sum of the RPM. When I am increasing my duty cycle, at the time motor RPM will be increased. When I am decreasing a duty cycle, at the time the motor RPM will be decreased. Okay, so this is the concept of electrical vehicle. Okay, so the motor controlling part. So here, so I am sending a battery supply from directly from motor controller part. Okay, so after that I am waiting for the control signal. Okay, so whenever I am applying an acceleration, so at the time based on the acceleration how much, like I am 50% of acceleration I am applying means based on the entire voltage I am sending a 50% of voltage from the motor. Okay, so at the time based on the input voltage level, we are controlled voltage level based motor will be rotating. So finally we are connecting a vehicle part. Okay, so this is the one simple block diagram of the electrical vehicle system. Okay, so after that, the vehicle designing procedure. So one vehicle we need to design means what are the things we need to capture. Okay, so first one is the propulsion power. Okay, after that, the motor size and battery capacity. So example, so I am choosing one motor. Okay, so in this motor having like 1500 RPM. So in this RPM measure, I need to apply some power. Okay, suppose this RPM measure maximum the four members only will be possible to build right. Okay, suppose I need to travel my vehicle in a six members. So at the time I need a more RPM and more power I need to expect. Okay, so the power we can drag in from the battery, that is possible, but the motor we need to support right the maximum power purpose. So at the time we need to precise the motor size also. Okay, so that's why we can calculate the motor size. Okay, so like how much people we need to travel this vehicle maximum. Okay, so like suppose we can take in a hill station areas. Okay, normal areas is there. Normal areas you are traveling like a six people in a one vehicle means like a four-wheeler vehicle, six people you are traveling. Okay, so at the time your vehicle will be smoothly will be running. Suppose you are running your vehicle in a six people at a hill stations areas. So at the time you are facing some problem. Otherwise you need to give more energy to the motor. So like that time only the vehicle possible to will run in a hill stations, right? So this kind of the things also we need to check, like a power propulsions and motor size and batteries capacity. Okay, so these things we need to capture. So battery capacity also how much power you are expecting based on your motor size. Okay, how much motor size you are fixing based on the motor size you need to how much battery capacity you are expecting we need to capture. Okay, clear? So next one is the vehicle basics. So take one vehicle. So basically one vehicle, what are the force and what are the environmental conditions we need to face? Only we can capture the electrical vehicle and like body vehicle and inside driver vehicle. These things is enough like that we can thinking that is wrong. Okay. So why means this is for inside of the vehicle things, right? But outside also we are facing some problem. Like a example we are taking means aerodynamical drag force. Okay, so air density, friction force, and pushing force. So this kind of the things also is that this is everything will be outside of the electrical vehicle. So we are capturing inside of the electrical vehicle weight and driver mass, and this everything we are calculating like a motor weight and battery size weight. So this everything we are capturing. We will design one motor power and motor range of power we can design. This is for only inside of the vehicle we are capturing. But outside also we are having some disturbance, right? Like a disturbance means or like a air density. Okay, so opposite air density we need to check. Example, your bicycle is there. Okay, so bicycle one weight is there. Your one weight is there. You are giving some force to the movement purpose. We will apply some force. Okay, based on the force, the vehicle will be traveling. Okay, so like the cycle will be traveling. So you can consider so more air is there. Okay, in my friend like opposite side, more air density is there. So at the time, the same force I need to apply, or I need to apply the force. I need to additionally I am applying force means only possible to will be move the one bicycle. So what is the reason means opposite I am facing some air density. So based on the density, I need to increase my force level. So this same thing in the electrical vehicle parts also. Okay. So we are having a frictional force. Frictional force means we are rotating, rolling resistance force is there. That is called a frictional force and pushing force. Pushing force means the backside area, any air density is there means based on the pushing force we are facing. So this kind of thing. At the same time, aerodynamical drag force. So what is aerodynamical drag force means? So our vehicle body structures. So which structure we are doing? Example is swimming pool is there. Okay, one swimming pool you are diving. You are diving means the divers will be maximum will be sharp portion only will be handling from the diving portion. Suppose the flat portion we are following means we will get some problem, right? So what is the reason? So the sharp portion easily will travel inside of the uh, so inside of the like a water. Okay, suppose we are traveling in a flat surface means we will facing some problem. Okay, so that is the same thing from a air also. Okay, so air side your flat surface will be more pressures we are handling, right? So we are short surface means we will facing some less pressure. So that's why the aerodynamical drag force we need to calculate. Okay, and frictional force and gravitational force. So these are the additional outside forces. Okay, one power I need to calculate means so total tractive force and velocity of the vehicle. This kind of the things I need to check. Okay, so after that the force on the electrical vehicle. Okay, so these are the forces electrical vehicle. What are the forces we need to calculate? So rolling resistance force, aerodynamical drag force, hill climbing force, and acceleration force. The acceleration force, linear acceleration and acceleration. So two types of things is there. Okay, so this everything we need to monitor. One at the same time, one vehicle how we can design it means 45-degree angle is the maximum angle of this the vehicle will be traveling. Okay, hill climbing areas. Okay, above 45-degree means you will facing some problem in a vehicle side. Okay, so maximum angle every vehicle we are designing from the 45-degree angle. 90-degree is angle possible to will travel any vehicle. It is not possible. That is not possible, right? So that's why maximum angle we can keep in a 45-degree. Above 45-degree means also we need to apply a more pressure, we need to more acceleration energy we need. Okay. So, so rolling resistance force. So what is the rolling resistance force? Okay. So I am giving you more theory. So no need for more theory. So you can mention this kind of the formulas. Okay. So I don't know the physics. Okay. So this is everything will be comes under the physics side. Okay. So you need to apply the physics area. Okay. So this formulas I am find out in the physics area. Okay. So here I need a mu r like a rolling resistance constant value. After that, mass of the vehicle and gravitational acceleration constant. Okay, these values I need from the vehicle. So these values I need to capture from the vehicle. After I need to apply this formula, means I will get the rolling resistance force. Okay, same thing from the aerodynamical drag force. So already I said right. So air density based, we are facing a high pressure and low pressure. So, like you can assume, your vehicle will be moving in this direction. Okay. So at the time you are facing more air density from in this area. At the time high pressure we are handling from in this area, right? So in this side we are facing a low pressure. Okay, so this is considered of the aerodynamical drag force. So in this aerodynamical drag force will be different types we are capturing based on the vehicle structure. So you can see here, I will give some structure from the here. So first one, so this is old type model. So in this drag coefficient value will be 0.85. What is the reason means inside two flat surfaces there, right? So this is one flat surface and this is like a L type. Okay. So this kind of vehicle we are facing a more air density forces. Okay. So that's why we are calling drag coefficient will be 0.85. Suppose I am capturing sorry. So suppose I am capturing this kind of the vehicles. So here I am facing comparing to this vehicle, I am facing a small amount of drag coefficient. So what is the reason? Means the L type will be little bit slope type I am getting. Okay. So at the time I am getting a 0.50. So example this one 0.45 and 0.23. Okay. So this is the aerodynamical drag force. So I hope everyone understanding this concept. Okay. So these things we need to capture from the vehicle. These things also we need to calculate. Based on the calculation only final power we need to calculate. Okay. So after that the hill climbing force. So one vehicle already I said 45-degree is the maximum angle from the vehicle. Okay. So this is the hill climbing force. We can find out the value. So mass of the vehicle and gravitational force and sine theta. How much theta I need to run? Like how much degree I need to run in this vehicle. Okay. So after that, acceleration force. There is the angular acceleration force and linear acceleration force. The formulas I am giving in a total this area. Okay. So in this formula based, we need to calculate the total tractive force of the vehicle. Okay. So the total tractive force we need to calculate means we need a like a rolling resistance force and angular aerodynamical drag force and hill climbing force and linear acceleration and angular acceleration force. So this kind of the things I need to calculate first. After finally I need to calculate the total power of the system. Okay, how much power I need to record from this vehicle. So in this angle I need to travel this vehicle means how much power I need. So based on the forces we can calculate. Okay. So actually this is I'm giving some small rating values with using of Excel sheet. Okay. So here I am already calculating the 40 kilometer per hour. So already you know the formulas, every formulas, right? So please you can try to your work will be I am speed limit will be 40 kilometer per hour. I am calculated. Just you can try from 50 kilometer per hour. So how much you are facing? You can increase the vehicle weight also 1500 kilograms. Okay, this is from your work. Okay, so I will give some data. The same data you can follow, but you can change the vehicle mass. Okay, weight is the right weight you can change to 1500, and speed in kilometer I am giving 40 kilometer. You can change to 50 kilometer per hour. Okay, so you can calculate the value. Based on the value, you can try your own vehicle from your MATLAB. Okay, so you are understanding, right? Okay, so this kind of values based, we can calculate the values. After finally my 40 kilometer per hour, this kind of the value parameters is there, means I need a 1890 watts. Okay, so this is the total power of the system. Okay, this much power I need to drive one vehicle. Okay, this is the entire thing. Okay, based on the formula only we are calculating this section. Okay, so this is the power and curves. Okay, so power and vehicle speed curve. So this is a sample data. Okay, so directly without any delay we can go from the designing part. Okay, this is the sample data from the our now we are designing electrical vehicle purpose. Okay, so I hope everyone having a laptop, just take your laptop. Okay, side by side I will tell the procedures how we can design an electrical vehicle. So please follow the procedures. Okay, so first of all, everyone take your laptops and open your MATLAB. Okay. So any versions. Okay, no problem. Maximum I am using a 2023A. Okay. Suppose you are having any versions means no problem. Maximum try to capture the above 2020 versions. Okay. So at the time only you will get some proper outputs. So this is my MATLAB. So everyone know about the MATLAB. So MATLAB is the one type of mathematical laboratory. So in this MATLAB, we are designing electrical vehicles. Okay. So with using of MATLAB. Okay. So mathematical problems we can solving purpose we are using a MATLAB. Okay. So here the MATLAB, this is the front window. So actually this is the front window. Okay. So this is the front window. Here we can do the solves like the problems and calculations. Everything we can solve from here, and the command window also we can solve. Okay. So like a encoding parts is available. MATLAB you need to learn means the individual part is there. More than things is there in MATLAB. So now we can no need to go from the MATLAB detailed parts. Okay. We need to focus on the electrical vehicle designing. Okay. So you know what the MATLAB is. Just open your MATLAB, and here the options will be available. Simulink option, the Simulink option, blank module one option is there. Okay, so just click the blank module. Okay, so first of all just click the Simulink home place. Simulink one option is there. Click Simulink. So after that, just wait for some seconds. Okay. Okay. So after opening the Simulink start page, so here we are having a Simulink option. Okay, blank module Simulink one option is there. Okay, just wait for some seconds. Okay. So the blank module we can create. So here already I create a module. Okay. So this module is the right blank module. Just you can click, the automatically the blank module will be created. Okay. So already actually I'm created. So that's why I'm not creating again. Okay. So this is my blank module system. Okay. So here library browser is there. So and save and open new files. All options will be available. At the same time, data inspectors like logical analyzer, bad eye view, simulation manager. So lot of options will be available. We no need to check all options. It will be go for bigger. Okay. We will check some whatever important thing to will design an electrical vehicle. That things only we can check. Okay. So here the main thing will be first of all will search one by one components. Okay, so my best suggestion, you can try to install the above 20 versions above. Okay, so 2021 or 22 or 23 above. Okay, so why, what is the reason means, so in old versions we need to all blocks we need to search in the library, but so now the current versions directly we can double click your mouse, you will got the blocks from here. Okay, so that's why we can try to install the new versions, like the current version will be 2025. So suppose 2024 also is available in Google's. Okay, try to install the MATLABs. Okay, so now first component, the component names also will be very important. Please make sure the components name. Okay, please note your notes, so next time you are designing time it will be very useful. Okay, take a whole like a vehicle body. Okay, so type vehicle body. So we are getting a vehicle body, driveline and tires and vehicles. One of components is there. Just take the component. Okay. So the component it will take some time. Just wait for some time. Okay. So after that, so actually this is the electrical vehicle body. Okay, not for electrical vehicle body. Okay, we will design then it will comes under the electrical vehicle side. Okay, so here what are the things is that the major things. So actually here I am having a NR. NR means like a front axial. Okay, front axial. This one is the rear axial. Okay, so NF is the front axial and this one is the rear axial, and this one is the axial place and velocity and wind input. Wind input means already we know aerodynamical drag force is there. So air density we need to apply, how much air density we are facing in a frontal area. So that's why we are giving a wind input, and this one is the beta. So beta means like a terrain angle. Okay, terrain angle, how much angle I need to travel in a vehicle. Okay, so that is terrain angle. Okay, so first of all just take the electrical vehicle body, you can search. After that already we are having a data, right? So here we are having a all data from in the data sheet. Okay, so just you can consider. So double click the vehicle body block. So your double clicking means, so inside the values we can apply. Okay, so the values I will tell one by one. Please notes, take a notes from side by side and take a side by side, you can design in your system also. Okay, so double click the block. So you will got the parameter values. Okay, so here, so lot of things is there. Here whatever things we need we can apply, whatever things we are given data is there, the data only we can apply means is enough. Okay, no need for any additional. Okay, so first of all, first one is the mass is there. So mass means how much mass we are giving here. So in this data we are giving it two types of masses. So one is the rider mass and another one is the vehicle mass. Okay, two masses we are giving. So the vehicle mass will be 237 kilogram. Okay, so at the same time 80 kilogram. So now we need a total mass of the vehicle. Total mass of the vehicle means 237 plus additionally we need to add the rider mass also 80 kilogram. Okay, so this is the total mass of the vehicle. Okay, so total mass of the vehicle, so like that you can apply. The total mass of the vehicle will be 317 kilogram. Okay, so kg. So you can see here, so kg only we are given. Okay, at the same time the unit also very important. Okay, so after that, number of wheels per axle. Okay, so now we are designing a two-wheeler system. Okay, so now we need to design a two-wheeler system. So one axial, two wheels. Okay, one axial, two wheels. Two axial means four wheel. Okay, now actually default to four wheel system axial is there. Now we can change from a one axial. So now one axial means two wheel we can connect. Okay, it is possible to will connect. Okay, so this one we can change. After that, horizontal distance from a CG to frontal axial. Okay, so frontal axial area we need to capture. So actually this is the frontal area axial 1520. So this is the frontal area axial in millimeter. Okay, so mm. Okay, so this is the frontal area, right? Sorry. Okay, so 1520 you can change from mm. Okay, actually meter is there, you can convert to the mm. Okay, so same like that. So the rear axial, okay, 1400 data is we are given. Okay, this is the rear axial value. You can apply the rear axial value in the EMM. Okay, okay, so next one is the height above the ground. Okay, CG of the height above the ground. So height above the ground CG value already we are giving. Okay, 254 millimeter. Okay, so you can apply here 254 4 millimeter. Okay, so mm. Okay, so the data I'm taking from in a MATLAB. Okay, suppose you are having any individual data means the data also you can use it. Okay, which like which measurement you are using, based on the measurement you can use. Here a lot of measurements values is there, inches is there, ft is there, centimeter is there, meter is there, mi is there. Okay, so lot of is there. So whatever data you are capturing from the vehicle side, the values you can use from here. Okay, based on the unit also you can use. Okay, and after that, gravitational acceleration force. So here we are not giving any gravitational acceleration force, so you can keep it from same value. Okay, no need for that value. Okay, so after that, here the frontal area, so value is there. Frontal area, how much we are giving? So frontal area, so 1.33 millimeter, so meter square. Okay, so 1.33 meter square we are giving. So please enter the value from 1.33. Already default meter square only is there. Okay, so after that, drag coefficient value. So here drag coefficient value will be 1.2. So just apply the 1.2 value. So here any unit is not there. Okay, just apply 1.2. And air density. So air density here, how much we are giving? So we are not giving any air density value. Okay, so no need to change anything. Just keep it whatever is there. Just keep it. Okay. So after that, the pitching angle. So here pitching angle and remaining anything is no need. Okay. Okay, clear? So remaining everything, just keep it same. Okay, whatever data we are giving, the data only you can take. So at the same time, this block will be automatically apply the values. Okay, no need to click any OK or anything, no need. Just automatic apply is there. Just keep it automatic apply. Okay. So after applying these values, now our vehicle body values will be there applied. Now our vehicle body will be ready. Okay. So now the next block name will be tire from magic formula. Okay, tire magic formula. Type tire magic formula, so you will got the tire. Okay, so this is actually, this is the tire. So in this tire we can use from our vehicle. Okay, so just rotate the component and fix it. So here you are having a, so rear axle. Okay, the rear axle you can connect from here. Okay, this is rear axial. Take, so before that you can enter the values. So already we know, so rolling resistance on force we are calculating. That purpose we are giving some parameter values. The tire B, so berth and tire C and tire D and tire E. So this is for four-wheeler systems. Okay. So here we don't need any one single two-wheeler system we are capturing. So the tire diameter is enough. Okay. So just to open the tire parameters values. So here what are the values is there? So first of all we need to change to constant magic formula. Actually default peak magnitude force and corresponding slip is there. So please change to constant magic formula coefficient. Okay. So after that, so the values will be is there. Okay, the values, default values you can take the same values only we are also given. Okay, so you can see here, so 10 and 1.9 and 1 and 0.97, the default value only we are given, so no need to change anything. Okay, so after that, the rolling resistance value, the rolling resistance value here we are giving. Okay, the rolling resistance value will be 0.05. Okay, so please ensure the value. So sorry. So first one is the rolling radius value. Okay. So rolling radius. Actually, we are giving a diameter, right? Tire dia we are given. Okay. Tire dia equal to 18 inches we are given. So dia is a 18 means. So radius means 9, right? So half of the inches. Okay. So here inch you can click. Okay. Unit also is important. You can must you need to change the inches value. Okay. Okay. This one you can change. Okay. So after that, so we need a here, so rolling resistance values. Okay, just to model rolling resistance, one axis is there, just click, and here the coefficient, constant coefficient value is there, right? The value you can change to the 0.005. Okay, so rolling resistance value you are giving the 0.005, so that's why I'm changing this one. Okay, so remaining everything is same. Okay, so after applying, just close this block. So now almost we are given data we are completed, right? So take one more same tire block. So take and fix it here and connect the NF. Okay. Sorry. So this is axial. So here you can connect. Okay. Okay. So after connection, So we need a one PS constant block. Okay, so PS constant block. So every block's name will be important. Suppose you are don't know the component names, so it is problem. Okay, you know the component, every component. What are the components we can use? Okay, just you can connect here. At the same time, the wind. Okay, input wind purpose we can connect from here. Okay, so actually the default any wind is not there. I will keep it from 0. Okay, I no need for any wind calculation. Yes, okay, but the constant actually angle. So angle I need to calculate. Actually, this value we can give from a radians. Okay, radian value we need to apply. Okay, radian value we need to apply. Unit you can keep it from radian. Suppose my vehicle will be traveling from a 10-degree angle. Okay, you can consider 10. So I need to convert to radian means multiply with pi divided by 180. So this is the formula from radian conversion formula. Okay, so 10-degree angle I need to travel my vehicle. Okay, so this is the conversion formula. Multiply with pi into 180 is the multiplication value. Okay, so like that you are calculating time, you will got the radian value. Okay, okay, so just you can close this one. Okay, after applying, just close it. So after that, so we need a axles. Okay, we need to connect the axles. Okay, so already we are having axial from here, the hatch portion. So you can connect here. Okay, so this axle will be common from both. Okay, okay. So after that, we need a scope block. Okay, take one scope block. So take one scope block, and here you can connect. So before that, we need one. So ideal rotational motion sensor. Okay, so this sensor we need ideal rotational motion sensor. So in this sensor too we can capture the speed and everything. Okay, so this is from velocity. Okay, so in this velocity you can connect from the scope. Actually you can see here we are using the components will be simscape components. Okay, two types of library files will be available in the MATLAB. So one is the Simulink, another one is simscape. So we are using a simscape component. So we need to ensure the Simulink means, so we need a one another connector, PS to Simulink connector. So what is the reason mean? Actually this block will be Simulink component. Okay, this block will be Simulink component. This is will be Simscape component. So both is the different libraries. Okay, so at the time we need to connect one library to another library means we need a converter part. Okay, so that's why I'm taking this block. So this is the velocity of the vehicle. So after that I need one, so rotational motion sensor block. So in this block I will connect from here. Okay, so this one I will connect from R. So we need one more mod. So before that we'll check the values. Okay, so we'll wait for some second. So that we'll check the values. Okay, so after that, so after connection, okay, so the every connection you are given, right? So after that we need to connect one. So this is one part of the vehicle. Okay, this is vehicle part. Okay, so after we need a, so additional one more part. So already we are discussed it. So one vehicle we need means we need a battery. Battery after we need some controlling mechanism like a motor controlling part. So after that finally only we need a, so vehicle body. Okay. So we are designing the vehicle body. Just keep it the vehicle body from here. So take one more simulation block. So this is one part of the vehicle. Just keep it that one. So after you can take from one more vehicle part. So here we need a, so now this is the system. Okay. So in this system we need a braking system. Okay, brake and a gear system, everything we need, right? So that's why we need to design first in a motor part. Okay. Take one DC voltage source. Okay. So that is already we are designing one is the one type of part. Okay, one part of the electrical vehicle. Just keep it that one. So after finally we can integrate the all components. Okay. So take one DC voltage source from Simulink like a Simscape component. Okay, like this type of components. Okay. So take this block and take one DC machine. Okay, so DC motor. You can type to DC motor. Okay, so you got the DC motor block. So in this DC motor, we need to apply some values. Okay, so the DC motor values will be, I will tell you one by one, each and the values. Okay, so keep it here. So double click the DC motor block. So actually here will be, so default will be by equivalent circuit parameter is there. You can change to by rated load and speed. Okay. So after changing, so armature inductance and load, no load speed and rated speed and this everything will be given. Okay. So here just you can change small of the components ratings. 0.005 is the my Henry. Okay, Henry value. So armature inductance value. After that, here you can apply from. So the no load condition speed without any load, the RPM will be 900. Okay. So and after that, 800 is the loaded speed condition. Okay. So fully loaded condition, the 800 RPM is the peak load. Okay. So after that, so we need to enter the rated load at a mechanical power. Okay, the mechanical power I am keeping from 2 e power 3. Okay, so 2 kilowatts. Okay, so this is the mechanical power and input DC voltage supply I am giving from 100 voltage supply. Okay, so this parameter value already I am calculations, so based on the calculating value I will take. Okay, so remaining everything just you can keep it from same. Okay, clear. Okay. So just close it and after that just you can connect this block from here. Okay. So after connection, so please apply the value from 100 volt. Okay. What is the reason means inside we are giving a 100 volt value. So that's why I am applying a 100 voltage from here. Okay. So after connection, just take one more block. So the block name will be solver configuration block. Okay. So type solver configuration block. So what is this block means? So actually we need a one library file. Okay. So the entire blocks having some library file. The main source of library, this is the solver block. Okay. So in this block we need to connect. At the same time, electrical reference block we need. Okay. Electrical reference. Okay. Take electrical reference block. Block we can connect from here. Okay. So after that, so mechanical rotational. Okay, so type. So mechanical rotational reference on block is there. Take this block. So in this block you can connect from here. Okay. So actually this is a one type of rotational reference. So here you can see. So blue color one part is there. Green color one part is there. So actually the blue color part will be the electrical parts. Okay. Electrical related parts. This green color parts completely from mechanical parts. Okay, so that's why the color will be different color is there. Okay, take one subsystem block. So we can assign one gear system. Okay, take one subsystem block. So after that we need one. So signal editor block. Okay, so just take the blocks. Okay, I will explain you. Okay, so the signal editor block you can take. So whatever the components I am telling, so please one by one you can take in your simulation. Okay. Finally, we can integrating time. I will tell you one by one clearly. Okay. Okay. So the block name will be mechanical translation reference. Okay. So take this block also, and we need some sensors. this block name will be ideal rotational motion sensor. Okay. So actually we need a ideal translation motion sensor block. Okay. So please take this block. Okay. So in this block we need to connect with our vehicle body section. Okay. So please go from your vehicle body section. Okay. So just copy these two blocks, just cut it, just keep it the same thing, everything. Okay. So one by one we can design. So, okay. So don't confuse. Okay. Complete explanation I will give you overall. Okay. So finally, so take the ideal translation motion sensor. So this one we can calculating the speed and everything. Okay, here we can calculate the speed and everything. Okay, just you can connect the reference, and this R part you can connect from in this area. Okay. Okay. So take two connectors. Okay, one more two connectors we need. We need to check the value of the output values. Okay, take this block and take one more scope block. Okay, take one more scope block. So this block inside. Okay, I will check the values. Okay. Just this one is the velocity of the vehicle and this one is the speed up. Okay, so speed of the vehicle. Okay, so just calculate here. After just connect here. Okay. So everyone, I hope everyone is following. Suppose you are getting any doubt or anything means, so please comment in comment box. I will clarify you. Okay, so just connect it. So after that, so we need a one solver configuration block from here. Okay. Without solver configuration block, you are running your simulation mean definitely you are getting a error. Okay. So please make ensure that solver configuration block in your system. Any one of the place you can connect it. Okay. In your circuit. Okay. So this is one type of library file for the access of the all components. Okay, so that's why we are taking this block. Okay, so now everything almost we are connected, so just we can check some values. Okay, so first of all just run your simulation. So what is the value you are getting, first you can check it. Okay, so actually our input value will be now 10-degree angle. Okay, so you can consider our vehicle will be traveling in a hill station. Okay, in now my vehicle will be traveling upside like a upward direction. My hill station feels my vehicle will be traveling. At the time I will get some more pressure and more force. So at the time my output speed will be negative. Okay, like a negative direction my slope is negative. Okay, when I am downward direction I am traveling my vehicle, at the time my vehicle slope will be positive direction. At the time I will getting more energy. So that's why, so like that we are getting output or not, we need to check from here. Okay, so actually here two output blocks they are connected. Just wait, I will double click my block. Just wait. So open your scope. So what is the output you are getting, once you can check. Okay, so you can see here. So actually my slope is going to the downward direction. Okay, right? So take it to layouts. Okay, okay. So actually my speed is going to the downward direction, right? So the downward direction it will be going. So what is the reason the downward direction means? My speed will be now will be my vehicle will be traveling in a hill station upward direction. Suppose in this constant value, I am changing from this constant value from minus 10. Okay, just I am adding a minus degree angle. Minus 10-degree angle means downward direction. Okay, the downward direction my vehicle will be traveling. Okay, so now I will run my simulation one more time. So now we can, what is the output we are getting, once we can see. Please run your simulation. Just wait. Actually, my simulation will be handled. Okay. So the subsystem inside I will place these values. Okay. Okay. So actually outside this block will be open is there. Just command out. Okay. So first we can check this outputs. After we can move from the next motor section. Okay. Just run this simulation. So now actually I am applied the minus value, right? So now what is the output value I am getting? You will check. Okay. So my simulation will be run there. So double click this block. So now you can see, so my slopes will be going to the positive direction. So what is the reason means my vehicle will be traveling in a downward direction, okay, in hill stations, okay. So suppose you are keeping in a 0 degree means it will be flat surface, like a zero angle it will be here, okay. You will check that one, okay. So now this part will be now we are completed, okay. So now we will go from a next part, okay. Just keep command out this block, okay. This one also you can keep it from here, this command out, okay. So next one we need a brake system, okay. The brake system is there, right? The brake system we need to, here we need to add, okay. So the brake system purpose one more block is there, I will tell you. So take one more subsystem block, okay. So double click, remove this one. So here you can type loaded constant rotational friction on block is there. Take this block, okay. So actually this is the brake we need to apply, okay. Loaded friction constant, okay. So in this block you can take, so after that take one step block, okay. Step. So totally we need a two-step block. So actually in this block will be working like a based on our time period. Okay. So here I will change this time period from 100. Okay. So initially I am getting from 10. Okay. I will change to this stop time will be 100. Okay. So change to 100 seconds. Okay. Let's change it. So so here you can fix the stop time when will be reaching 50. Okay, so suppose you are keeping this one is the rear brake means, so rear brake, front brake, two brakes is the right. So you keep first one is the front brake, second one is the rear brake, like that you can keep. Okay, so this one value you can apply from final value will be 100. So the rear brake will be, we can apply from the 15th instant. So what is the meaning of this one means my runtime when will be reaching a 50. So at the time the back brake will be applying from this instant. Okay. So this is the reason from here applying this one. Okay. Take one more block. Take a Simulink to PS converter. So now we are connecting Simulink block to PS converter block like a power system block. So that's why we need a inverse connector block. Okay. So in this connector block we can connect it here. Take one more block. Okay. So we need to apply the values here. So take one. So ideal rotational motion sensor. Okay. So so mechanical reference. Mechanical rotational reference part is there. Take this block and connect here. Okay. Just take two blocks so you can connect here. Okay. So now take one connection port. So connect this block here. Okay. Take one more block. Actually, this one is the front brake. Okay. Okay. So this one is the rear brake. Okay. Okay. So two brakes we are applied. The brake systems also will be completed. Okay. So actually here we need to apply some value. So the default value will be 130 is there. Change to 180 mm. Okay. Okay. So remaining anything is no need to change. Just keep it. Okay. So after changing this block, we will got the brake systems. Okay. Okay. So now in this brake system, I need to connect this block. Okay. So here our system is there already. So here the axial already is there. So this one is the rear axial. This one is the front axial. Okay. Take connection port and connect here. So rear axial. Okay. Just I'm keeping rear A. So frontal A. Okay. So we are having very less time. Okay. So I will go fast. Okay. So please. Okay. So this one actually rear, right? So please connect properly. Rear you can connect to rear and front you can connect to frontal axle. Okay. Okay. So actually my system will be now ready. Okay, so now almost my system will be brake system will be ready. So what is the brake system we are to capture? So the when the running time will be reaching a 15th instant, at the time the rear brake will be applying. So after front brake we need to apply. That is like that only we are giving, right? So just you can run your simulation. It is working or not once we can check. Okay. Just wait. Just wait. So actually my system will be a little bit slow. Okay. So now I will run my simulation. Just check the output. So in our total run period will be 100 seconds. Okay. So we need to change that one. So just wait for some seconds. Okay. So the stop time we can change to 100. Okay. So actually we are keeping 10, but in our step time will be 100 based only is there. So please make ensure to 100. Okay. Okay. So now we can run in my simulation. Okay. Check the output. Okay. So now we can check, analyze the waveforms. Okay. So you can see here. So actually initially my vehicle will be starting. Okay. So it will be reaching a maximum speed. So when I am applying 15th instant, okay, sharply the 15th instant, I am applying a first brake, and so like a 75th instant, I am applying a second brake, okay. So you can see here, this is the 15th instant, okay, it's visible I think, okay. So here this is the 15th instant. The 15th instant, I am applying a first brake, and second brake I am applying a 75th instant, okay. So I think so. Your hope understand. So we are applied the brake now. Okay. So we need a gear system. Okay. So the gear system very simple. So I will tell you one by one. Please take an components one by one. Okay. So first of all, we need one subsystem block from here. Take one subsystem. Okay. So in this subsystem inside, just keep input only. Okay. So this input only you can keep. So this input you can make it as a command. Okay. So command like that you can keep it. So after that we need a compare to constant.